Alright guys, welcome back, and this is going to be a series where we are going to be creating a 2D game in Java, a top-down shooter kind of multiplayer thing. We're going to be using IntelliJ IDEA and Adobe Photoshop. So, yeah. What we're going to be doing is we're going to make it multiplayer as well. We're going to have it so you kind of run around top-down from the game, shooting people and things in the game, and we'll make it so you like earn points as you kill people. Quite a basic kind of game, but it'll be quite fun. The source code will always be available in each video down in the description, so you'll be able to continue yourself and make your own kind of version. I wouldn't take this as a very literal guide. It's not going to be that intuitive, and things will be constantly getting changed. So as you can see, we've got a new project in IntelliJ here, and we've got the, if you didn't keep on closing it, we've got a blank Photoshop file. So we're going to be working with both of these through. And we're going to just kind of create it from there. It's got no start direction, we're going to just make it up as we go along. Nothing's really been finalized, but we're going to work on a kind of basic engine, and then we're going to work on working the actual game. So we'll start as an engine itself. We will build this from the ground up from pure Java. We'll be using JFrames and kind of overriding some of that code, so it's going to be quite cool. And we're going to make it so it can run on any screen dimension, and it will adjust itself. So as usual with Java, we're going to start by making packages and stuff. So I'm just going to call the first package engine, and we'll create a game engine class. Now what I'm probably going to do is have a game class and make game engine where you get the instance. So a private static game public static game get instance new game. We need to create a game class, new class game. Well, with store in the game engine will just be where you will get the game instance. So that's that class just literally done. From here we'll make it so you create the game, and we'll also create a package called game, and this will be where all the game logic is stored, and this is where the engine is stored. So we'll have a rendering package, and in there we're going to need to create the physical display, so game window, extends JFrame. We'll work this on top of the JFrame because that's probably the best way we can do this. So we're going to need a constructor game window so we can create the JFrame. We should probably define some final variables in here. Public static final string name equals YouTube. No, we need to go quadro. I don't know. That name will be subject to change. That's why we're going to put it as a public static final variable. So we can kind of just go like game.name when IntelliJ decides to load. Then we're going to want to set the default close operation to jframe.xOnClose. This dot set size. We'll just make it 720p for now, and then on top of that we'll change that as we go along, and we'll make it so you can adjust the kind of page so that it fits how you want it. So we've set the default close operation, we've set the size. What we're going to want to do now is we're going to need to create a class that we're going to have a JPanel inside of the I created a Kotlin file. Kotlin is a Java-based runtime thing. New game renderer, and we're gonna have this extend JPanel because we'll put this inside the JFrame, and this will be the kind of panel that we'd render in, because you can do override public void paint graphics G, because JPanel contains that function, so you can override that. And then we'll pass the graphics object here to whatever class is currently rendering. which we'll work out. So in the game, we're probably going to need frame. That's not a very good name. We'll call it, actually we'll just put it straight in the package, abstract game page. So each game page will override this, public abstract void paint graphics G, because then we only have one kind of panel that overrides, and we need to make this abstract. So then every class that override it must contain this function, which is fine, that will work. So we're going to want to this dot add. We're going to need to store an instance of the game renderer, because we're going to need to call repaint, which will repaint the entire game. So public game renderer get game renderer, return the game renderer. How are we going to do this? Can you do this inside a function? Yeah, you can. So we'll set, we'll add the game renderer to it, and we'll set the game renderer to new instance. Then we're going to want to set it visible to true, and this dot set location relative to null. That will center it on the screen, and you have to call that after you've made it visible, otherwise it's got nowhere to go to. So what we're going to do now is we're probably going to need to store an instance of that game window. Instance public game. We'll store a private game window. Game window equals new game window. Make it this dot because we're going to be passing variables, so it just looks nicer. Public game window get game window. So now we can retrieve that instance whenever we want it. We can make that package only, as we don't want to make it instanceable, but we want game engine to be able to make it instanceable. So now what we can do is, in the game we're going to make a main class that kind of just does the game. But thinking about it, game engine creates the instance, that's fine. Oh, but then this will need to, that should run itself because it's static. In here we'll store the public static void main string args. This will just start the program. We can, what we should do is make this equal to null, and then if game equals null, game equals new game, like that, because then it will still return the game object, but if it's null it will create the new one. So we can, in main we can just do game engine get instance, and that will literally, because it's run for the first time, that will create the game. And I'm trying to think, I think we're going good. So if we just try and run this, run main, let that build, and this should hopefully create a box to the screen. Yeah, there we go. So this is a bit boring, of course, because now we just got this box, and we need to, for now we'll not make it resizable, and then we'll work on the resizing kind of later. This dot set resizable false, and I just realized that should go before here. Okay, game renderer. So in the game we're going to need to store the private abstract game page current page. Yeah, we'll store the current page in there. We'll also store a private list abstract game page cached abstract game pages. So what we'll do is we'll make this dot current page equals null, this dot cached abstract game new array list. Because what we do every time we public void set current page, abstract game, we could do it so you pass a class that extends abstract game page class object. That should trying to think of how we're going to do this. Because we need to make it so you can pass in, unless we have each abstract game page as an ID. So each abstract game page contains its own ID and you call the ID. That would work. So if we need to create a for loop, cached abstract game pages, abstract game page, we'll just call it page. If page.getID equals ID, current page equals page, we're going to need to break, but that's not going to work because we're within a sub statement. So we will have to do braces. We'll break out of that. But then, of course, if it is continuing here, then it is there isn't a cached instance. So we need to find the abstract game page that does have that, which isn't going to work because we're not storing cached instances unless we have it so when you start the game you have to predefine all the abstract game pages. But then it's probably not a good idea to cache them, because if we're running like a lot of pages that have big maps and they've got a lot of RAM, that's probably not a very good thing. So I think probably the best bet is to register and deregister, which will still use the cache ones, but it will only use them when you want to use them. It won't automatically register them. That's probably the best way you can do it without causing any problems in relation to how much RAM we're using, because we can clean parts of that up and it won't cause a problem in comparison to if we didn't, we'd have problems. So what we'll do is we'll make it so you can set the current page from an ID, which essentially just does loop through the, we'll have this back, but we don't need the break, which means we can remove the braces. That just defines the current page, and that won't do anything if it doesn't exist, which is actually alright, because it should. We're going to need to make it so whenever we define a public abstract game page, abstract game page, you have to define an ID for it, because that's the safest way we can do it without causing any problems. This.id equals ID public ID int get ID turn ID, because that way every abstract game page must contain an ID when it creates it. So we need to make it so we can register abstract game page abstract game page cached game pages dot add game page public void delete cached abstract game page int ID, so you pass the ID cached. We need to use this exact for loop. In fact, we need to store an instance abstract game page to delete equals null. We'll loop through this, so if the ID then to delete equals page, because we can't remove inside this for loop, there will be concurrent modification exception. If to delete does not equal null, then we need to cached abstract game remove the to delete. So that means it has found it, because if it's null, then it hasn't found it because this value hasn't changed. So what we can go on to now is we can delete, we can create, we can set. We need to do it so we can get the current abstract game page. Public job done. Public boolean is current abstract game page defined. Return current page does not equal null. So essentially, if this is true, then there is a current abstract game page. If this is false, then there is not a current abstract game page. So what we're going to do now is we're going to head back over to the game renderer, because we can go if game engine.getInstance is current abstract game page defined, game engine.getInstance.get current get current page dot paint g. That way we paint the current abstract game page. So now what we do is we can create an abstract game page. So what we're going to do is we're going to make it when you create a game instance, you can pass it in. I'm just thinking, so you create the game instance, you create the sub page, and we need it so it repaints. So we're going to need to create a physics system. No, we're going to need a rendering loop. Physics doesn't matter yet. Render loop extends runnable. Yeah, we'll do that. That should be implement runnable. Okay. So then now when this runs, do all of this while true. And we need to thread.sleep 1000 divided by game.fps. So we're going to need to define the FPS. It should be a public static final int FPS equals 120 divided by game.import game. We're going to need to try catch this, and then we can do game engine.getInstance dot get game window dot get game renderer dot repaint. There we go. So we're gonna now need to, in the game, store the thread. Private thread game render thread equals. There we can define the game render thread. This dot game render thread equals new game render game equals new thread new render loop. So that's the runnable, and then we can do start the loop this dot game render thread dot start. Okay, so now if we create a new in the game, we'll create a package called pages. We'll create a loading screen, new class loading. We'll start all page underscore. We'll make it extend the abstract game page, and we'll have to implement all the methods that by default, and that create this. We'll create the loading page with an ID of 0, and we'll do g.setColor color.red g.fillRect 00 0. We're gonna need a way that works out what the resolution is, because game.width, game.height would probably be the best way to do this, which means in game we need to define public static int width height, because these are going to be variable on 280 because 720, because that way we can change them, because they're not final, otherwise I would have declared them along with the FPS. But as they change type, we can't do that. And we can remove that unnecessary import. And this way it should, with a bit of luck, just let it do, so it doesn't. Now why is that? Because we forgot. There you go, we've got to pass the loading page. So to register a page we can just do game engine get instance dot register abstract game page new page loading game engine dot get instance dot set current page to the ID of page loading. Let's start this back up. Yep, so now it's red and that's all rendering, which is great. So what we can do now is we can work on making it so there's like a basic home page. So we can just set this to, I don't know, black. G.setColor color.white G.drawString loading 100. We'll just always set this loading page whenever we're loading something. Now let's just close all, and we'll create the page underscore home. So we'll always have loading page loaded in RAM. It's literally nothing at all, so that won't cause any problems in that area. Let's create a home page now. Extends our abstract game page, which means we're going to need to implement our methods, and we're going to need to implement our constructor, where we're going to pass in the ID of 1, and that means we don't need to pass. We haven't really got any assets yet to work with, so we'll probably just do something quite basic. Set color, new color. Oh, I know what we can do. In game we're gonna store a static version of random, because we're gonna access that and it's just better, because then we'll have the same C public static final random it's new random. Oh, enter. We don't need to split into declaration. Hang on. There we go. Awesome. So what we do now is game.random.next float, game.random.next float, game.random.next float. Oh, we forgot to make that a new color. New color. No, we'll just create a new color, because why not? G.fill rect 0 0 game.width game.height. We're gonna need to make it so that you can actually start the game. So for now we'll just make it so you click like enter or something, which means we're going to need to make a keyboard system. So if we just start the game up now, we'll quickly add the game, and then that'll wrap it up for this episode. So game engine get instance register abstract game page new page underscore home game engine get instance set current page 1. If we start this up, this will kind of generate a random color. We'll do it a few times just to show you. And this is painful for my eyes. Yeah, we made it create a new color instance every frame, so that was going kind of mad, but that does show that it is rendering well. So next episode we will implement an input system where you can get keyboard input and mouse input. So see you then.